Now, once we know how to log our runs on MLflow tracking server, let us see what are the changes we'll need to make to our training script or our training component so that we can accommodate MLflow tracking. Now, what I'm showing you here is the model training component that we had written in the last part of our video series, where we had brought in everything together. But the only thing that was now remaining was how do you log metrics to MLflow. Now this is the original script, and these are the changes that I've made. You can see the only thing that you will see that I have changed is that I've included the MLflow log matrix, log model, and log artifact statements over here. And the other thing that is different from the previous part of the video series is that obviously there's an import of MLflow, and that's all I need to do to run this particular component with tracking enabled. And I've done these changes on my local system as well. Now, before I run my MLflow training pipeline, you would have noticed that in the last run that I demonstrated on this Jupyter notebook, we were setting up a tracking URI and we were also doing a set experiment, while in our training component, we are not doing any of that. The reason for that is we can set up some environment variables, or we can provide this information from the MLflow command line itself. And that's the recommended way. If you're running your experiments in a notebook, then this is what you'll do. And in case you are running it as part of the training pipeline, you'll set up an environment variable. So let me copy this and set up the environment variable first. I can just check if it has been set. And I can see I do have an environment variable which points to where my MLflow tracking server is running. Lastly, I will issue the MLflow run command, and the experiment name is provided as part of the MLflow run command. Now it will take some time to run, and I will get back once it has finished the run. Now the whole pipeline ran, and you can see it probably would have also stored the model artifacts and model metrics on MLflow server. It takes some time to run. Let's go to the MLflow server, and we can see there has been a new run, and let's click on it, and now we can see what were the parameters of the model, what was the path of X and Y components, what were the metrics we computed, and this is the path to the model which has been trained and stored on our artifact store on S3. And this time we are also storing the training data we used to train this model. So now there is a complete visibility on when this model was run, when was this trained, under which conditions it was trained, and our pipeline is sort of complete now. So this brings us to the end of the video series on creating training pipelines. There's a lot that can be said, and there's a lot that can be improved in this particular training pipeline. So for example, we are currently processing everything in our local system, but in a production environment, you might want to offload all the processing, all the model training to some kind of a cloud compute environment. If you guys are interested, I might take a stab at it. I might show you how to integrate, for example, SageMaker to do the processing remotely, and also to do the model training remotely, but use MLflow as an orchestrator. There are other things that we can also do as far as just the training pipeline is concerned. We've just used MLflow as an orchestrator, but it's not the only orchestrator that is available. You have something called a Kedro. Some people also use Airflow to orchestrate things. Do let me know in the comment section if you want to see more stuff on these particular technologies. I'll be more than happy to create one. I thank you all for taking the time to go through this video series. Maybe next time we'll meet over a new video series.